This conference will now be recorded.
Thank you very much. Thank you, Jane. Thank you. My name is Ryan, and I've worked in the Alibaba Cloud for about a year and 3 months, I think, something like that. And today I'm going to talk about Alibaba Cloud in general, because as far as I know, there are many people have heard of Alibaba, but not too sure about what Alibaba Cloud is doing or Alibaba is doing in general. So I give a in this talk, basically it will be 3 steps. The first section is going to be just talk about Alibaba Cloud in general with some high-level overviews. And second one, I'm going to talk about serverless in Alibaba Cloud and some product that I'm actually working on day by day. Just before that, I just submitted some code reviews just before joining here. And third one, I'm going to go out on a limb and doing some live demos, finger crossed, and hopefully things work well. And last one, of course, and FAQ, if you can ask me any questions. Okay, so let's start. Let me see if this works. Okay, so the first one is I'm just going to give Alibaba Cloud overview. Just like any other clouds, we have a global infrastructure. It's, I think, just contrary to most people might think it's a China play, we actually have data centers all over the world. We have, I think, this one is a little bit dated. I don't have a pointer. This one is a little bit dated. We have US West, US East, and we have recently just opened a UK data center with 2 availability zones. And then we have most of the Asia, so of course that's our main market. And overall we have should be 19 regions and 51 availability zones overall. So it's a global play. We also have planet scale cloud operating systems. We call it cloud operating systems. Basically, it's a giant distributed computing stack. So from bottom, you can see these are all in the data centers. These are the data center ones. We have this is the file system server. This is the scheduling server, and this is the network server, something like that. And then on top of that, we have tons of different services. It's pretty mature, and just like if you go to GCP, AWS, Azure, it's kind of comparable. Here is our main product, the IaaS ECS. It's called ECS. It's kind of confusing. It's basically the EC2, AWS EC2, and the IaaS is Azure. I don't know what's Azure's IaaS called. In GCP, it's called Computing Engine, I think. So that's the equivalent of that. We have all kinds of different instance types with GPUs, FPGAs, and big ones, small ones. I don't know how many of them are here last talk. They talked about, what's that name? AWS has special, no, it has Nitro instance. And at that time I told them we have similar things. It's called X-Dragon. That's the one with a specific FPGA that can basically hand over all the DOM 1 operations, so it can save. We call it bare metal because it pretty much has the bare metal performance, but with virtualization on it. And we also have, you can see we have the top velocity, security, stability, which all its SLAs are the same as or better than AWS or Azure. But durability is, I don't know how many, 999s. That's our compute service. And we have the network service, network products. We have the VPC, which is the basic, the most important part of the VPC. Have one. We have all the management interfaces, SLB, NAT, Elastic IP. We also have a hybrid cloud. That one is pretty important because in China the main markets, the public cloud is not as popular as here. Just when I joined Microsoft 10 years ago, when I was doing Azure, actually that time it was called Red Dot. I don't know if anyone remember that. Same thing. That time the public cloud is not so popular. So at that time we also had a lot of hybrid play. So here it's a very important part, which is the Express Connect. Basically allows the private domain, the on-premises network, to be connecting to the cloud, so that they can have some workload running on the cloud and some running on premises, and they can communicate. That's actually a big product. We also have a global network. Those are I'm not a network guy, but the network guy told me that's pretty impressive. They cover all the bone, the internet bone network. They can connect into that directly, something like that. Don't quote me on that, but it's something impressive. And then we have the storage service, right? We have compute, we have network, and then you have to have the storage. So the storage service, we already on a scale of exabyte storage, millions of users, and all these regions and the things. So what I'm trying to get is we have 2 or 3 different layers, right? The bottom layer is the hybrid layer. They are basically crossing both on-premises and on the cloud. The middle layer is the more traditional public cloud type of thing. We have file storage, which the file storage has the NAS, which is equivalent to AWS EFS. Basically, it's a network attached NFS or Samba attached file volume you can attach to an instance. We have object store, basically is AWS equivalent S3. We call object store or storage service, object storage service equivalent to S3, which is the biggest service in the storage part. And we have block store, which is the EBS, and the other table store, which is the DynamoDB and the SLS. So just give an overview. Those are all the storage services we have, which is pretty impressive. And on top of that, because just the storage alone, normally you cannot do much. Right? You have the storage use, maybe you upload your photos and that's it. If there's no compute, no business analysis on top of it, data is just worth nothing, right? So within that, we have the content-aware storage, we have intelligent media management. Those are all solutions that targeted towards specific usage. For example, the content-aware storage allow you to do snapshots, allow you to see the previews, things like that. And then we also, on top of that, we have batch compute and function compute. Batch compute is more traditional batch style compute that you in-queue a job. If any of you have done the old style HPC type of work, you in-queue a job and then the job will run. And function compute is the one that I'm going to spend more time talking about later. That's our serverless compute offering. So that one is it actually tied up all these services, and you can use this to work with any of the other services. It's equivalent to basically AWS Lambda, if you're familiar with that. And then the last thing is we have tons of database products that I cannot count. So we have RDS, NoSQL, and we have a special one, the PolarDB one. And recently, Ghana has put us into a Visionaries quadrant. And if any of you are database gurus, you can give it a try and see which one you like. I think there must be one that can suit your need. They all come with different types, and I think that the first 4 RDS ones that they're basically hosted services, and we also have Radius, MongoDB, yeah, you name it, pretty much we have all these. And PolarDB is the special one for the. I'll mention that a little bit later. That's for our special needs because Alibaba has something that is pretty unique. But before that, let me just show you. I don't expect anyone to really read this graph. It just shows you how many services we have across compute, network, storage, database, web DevOps. DevOps basically is if you're on the cloud, you have to have these basic services, RAM, ROS, and then on top of that, we have some solutions, AI, big data, IoT, all these things. Just give you an idea how many services we have. This is just actually a very concise version. We have way more than that, but those are the main services we have.
Sorry, I don't have my glasses on, but do you have security?
Security.
I didn't see it on any of the other slides.
RAM is one of the security ones. This is security. Monitoring and securities. Let's see what we have. We have server guard. I have anti-DDoS. Anti-DDoS is actually really, really important in the public. Any of you, any of the services that want to be successful, they eventually will attract DOS attack. And we have, I think in the previous slides in the ECS, if you buy ECS, we have a default DDoS suite free. but it's by default, so probably it's not as powerful as it's customized, but it should be able to find out most of the common ones. We have DDoS, we have Cloud Shell, Cloud Monitor. I'm not 100% sure what does Cloud Shell do. I know DDoS, I know KMS, that's for the key management. You have to have a key management service in the cloud. You don't want your secret key flying around in plain text. We have Action Trail, that's for the audit. If in your services, normally you need to include the Action Trail so that you know who's doing what, and then you can have the audit. Just to name a few. Any other questions? That's a good question.
So what technology are you using to defend against DDoS?
That I'm not a DDoS guy. I don't fully know. Very high level, I can tell you it's very, very basic. Again, don't quote me on that. It's kind of just need some way that identify the source and quickly and block that source. That's the very high level idea.
So if there's one annoying source.
Maybe not one. It has to be huge. So they are basically it's like mouse and cat and mouse, right? They want to come, you want to catch them. You want to catch them. So we're now getting to the point of we catch them before they come. So before that, it's always you catch one, you see how fast you can blacklist this guy, right? Now we're getting to the point of using AI. I know they have talks. That part I didn't just come off top of my head. They have talks like they now have AIs. See how your patterns. We're going to block you before you even come. So that's the type. But again, for DDoS, there should be another security guy coming too. If you're interested, we have security guys. We can do another talk. Any other questions? Okay. So I was mentioning here, yeah. I was mentioning why we have a Polar DB. That DB is specifically for this type of carnival or extravaganza things. I think I don't know if any of you heard of Double 11 festival, shopping festival, something like that. It's supposed to be how many? It's 168 billion GMVs on that day. Billion. It's a B. I don't know how they get that, but the whole world, the whole nation, and now it's even not just China because we have Alibaba has many other partners and subsidiaries that actually is working in the Southeast Asia. So including all these, we predict that this year is going to be at least 200 billion GMVs a day, something like that. So GMV is the gross merchant value. So because the model of Alibaba's Alibaba, not cloud, just Alibaba, like AWS, the Amazon's retail part, right? So the revenue is just say if I sell someone, I sell you $1. For the Amazon's revenue, maybe it take a 10% cut, so it's 10 cents, and then the income becomes in Amazon case pretty much zero. But GMV is that dollar is the GMV, general merchandise exchanged on that platform. So that's the GMV. So that's basically it's like 200 billion because we are like only a few weeks, 2 weeks left. There's going to be 200 billion goods worth of goods that exchange hands on that day on that platform on the various platforms under Alibaba. Alibaba has so many platforms. I'm going to get into that. So it's just to support that type of transactions because those are transactions, right? You cannot buy something and then disappear something. So PolarDB is specifically for that, and according to them, you can also use that. So that's the those are the but we'll see. This year it's just 2 weeks away. Okay. Any questions before I move on to the serverless part of the Alibaba Cloud?
Actually, excuse me for being an
No
ignorant American, but
that's why I'm here.
right. How does that translate into actual dollars?
Yeah, I think their value here divided by 7, something like that. Divided by 7.
25 billion.
Yeah, this is a 25 billion. Yeah.
Underneath the bottom.
Yeah, 25.
US dollars.
It's tiny, and I don't expect you to see it. 25 billion last year, so this year will be like 30 billion a day GMVs. It's a B. Yeah. Nowadays we just put B around easily. Anyway, any other questions? Okay, you can always ask me questions in the middle of my talk. So now we are going to more specifically, because you can see that we have so many services. Every service someone can come here and give an hour to a talk. I won't be able to do that. So I'm just concentrating on what I'm more comfortable with, which is the serverless part of the the whole package, right? Serverless. So this is I think or this is Ghana, yeah, I guess. This is coming from 2017 Ghana. So basically, supposedly the trend is coming from you get a VM, you get a container, now you don't even have anything. So that's the. I wish I have a point. So on the left side, you can see the VM as a scaling unit. So people 10 years ago, right, when EC2 first came, people actually I was in EC2 at that time. I think people are actually pretty enthusiastic about it. I can get a VM on the cloud, and they just do whatever you want to do. I log into that, do things. And after a while, you have to maintain those VMs. You kind of become other than the inventory part, you still have to maintain all these VMs. So it's kind of getting difficult. And then the VMs are more heavyweights. I don't know. I remember initially when you want to get a VM, it takes maybe a minute. It doesn't come up. Last time they made a demo, that was fast. But 10 years ago, it was not like that. If you want a 500, you will not get it. Maybe a day. It's slower. And then I think in 2013, 12, something like that, Docker comes around. They have this container thing, super fast. We also have this image. You can have an image, container image instead of VM image, and can boot up your thing like within a few seconds. So people are like, great. But then same thing. And then I think it comes to the Kubernetes thing, right? The Kubernetes. I'm not a Kubernetes expert, and one of the reasons is first, every time I try this thing, it just has I don't know if any of you are expert. You can teach me something. It just has so many configurations you can all the knobs you can turn, and all the APIs I look at that is like huge. It's kind of daunting, at least for me. So now we have the whole serverless. Again, it's good for me, my type of thing. I don't want to deal with all these things, system admin type of thing. I just want to do my logic, right? Do work my algorithm. I have a fantastic algorithm, but half of my time is dealing with, disks, machines, networks. They all break. I don't have the time to do that. So that here comes the serverless. And I see on the right side, it says basically the more from ISS to PaaS to FPaaS. FPaaS is like a new name, PaaS. The more you go to this side, the more time you spend on your logics, on your own business logics. But at the same time, the cloud providers needs to do more. Now before that, on the VM side, they all need to do is put down the image onto a VM and send it to you. That's it. They don't need to do anything. On the PaaS side, they may need to run your applications. And on the fast side, we have to take care of how provisioning, security, auto scale, routing, all these things we have to take care of. I'll get to that more later. So here is another thing. We give an example. They use, I think this is Google's its own example, right? I don't know if you can see clearly, but just if any of you are familiar with the Google's term. So on the left side, it's compute engine, right? That's the VM thing. Basic layer, it's VM, and then it's Kubernetes engines. Basically, that's the container engine, Kubernetes engines, and then app engine. App engine is something interesting. Google had this thing in the first 10 years ago. It started with app engine. It didn't start with cloud engine. It started with app engine. So they now claim that they have the earliest FAS. But anyway, so that's a PaaS. And then now they have the cloud functions, which is a FAS. Cloud function is just like AWS Lambda function FAS. You can see this. It's this graph is really good. It says on the left side is more configurable. For those people who like to tweak your own services, tweak your own environment, that's the best. You can do whatever. But on the right side is more agility. You can do things fast. Because they actually did a survey. They did a study, actually. Google is really good. They have a lot of people. They can do a lot of things. To do a simple work, hello world, just from start, hello world, right? If you do a function, cloud functions, 15 minutes. You write maybe 10 lines of code, figure out a few things, sign up account, 15 minutes, hello world. Then the app engine, remember that's the PaaS, 1.5, compute engine, the VM 4.5. The interesting part is the Kubernetes engine. Kubernetes is supposed to see the order is supposed to be in between, but it's 6 hours. Kind of verify what I mentioned. Every time I look at Kubernetes configuration, I was like, I don't understand. Yeah, just a daunting task. So that's how it works. So you can see the cloud function, the fast. So you can really learn something really fast, easy. That's the fast. And now here's the Alibaba Cloud serverless platform. So one thing I really want to emphasize is serverless is not just one service. It's not like Lambda or function compute or GCP function, Azure function. Right? This compute alone is not useful. It has to do with all the other platform, all the other serverless services on that platform. So for example, here on the Alibaba Cloud, we have, so you have compute, you always have compute at the center. Like, without compute, there's not much you can do. But what does the compute can do? It has to have connected with all the event sources. So that's the key thing. It's otherwise it doesn't have much difference between fast and pass. Pass, you also can do something like that. But the fast has a lot of event-driven things. It connected with all the other services. I'll mention that a little bit later too. So you can see we have a whole bunch of cloud serverless platform. My definition of serverless here, again, this is really a loaded word, buzzword. Everybody is serverless. Just kind of loose definition is you don't have to maintain a server. You don't have to worry about your resources. All of these are like that. The service is on the cloud side. You just use an API call. You call it. You get what you get the response back according to specific API specs. So every one of these services has a very strict API spec on what's the input, what are the parameters allowed, what are the parameter valid values for each parameter, and what you get out of it. So all of them are like that. And is one of them, and we also have elastic container instances. That is more on the borderline. I'm not 100% sure if we can categorize it as a pure serverless one. But we have a serverless Kubernetes. That's another interesting thing. There's Kubernetes, you remember that six hour thing, and you put into serverless. Maybe it becomes 3 hours. So I don't know. So those are but function compute definitely is the really fast solutions here. And you can see have message queue. Those are messaging services. It's like pipeline of doing things. You also need analytics, right? When things come in, especially with log, somewhere there must be a log service, right? It's a very common case. You want to have dump a lot of log. Your apps dumps a lot of log, but log itself it doesn't tell you anything unless you do, you do data analysis on it. Then they can tell you a lot. What other things? Who is using you? Why they are not using you? Why they are using you? Where's broken? Everything there. But anyway, now I'll show an example later. Let me see. Any questions?
I'm curious. Talk more about the way you orchestrate things. In particular, have you built or are you building anything, analogous to say AWS Fargate?
Yeah, Fargate is this one. Oops. Fargate is actually this guy. FC. This guy. Elastic Container Service instance. This is the equivalent of Fargate. Yeah. But as I mentioned, even Fargate, right? You get what you get. You get a container. You didn't get what you really. You still need to. If you get say 1,000 containers, you still need to manage those containers. You need to return them back. You need to add more, and you need to connect them together, right? So that's why I say in my mind, it's not really a serverless offering, but it's a building block to build services. You can do someone can use this to build a serverless offering for your customer. So that's something you can use. In itself, it's not. At least my definition is not a pure service offering. Right, we have this. Yeah. So that's a good segue. Like basically, we can see we have these real serverless. That part. That's the real serverless servers. And then we have application management. It's still, again, serverless is a loaded word. Many people are just putting everything like serverless, but pure serverless is more like just the middle ones. Then we have orchestrations. Where provisioning, that's why it's called provisioning. So this is provided, basically the ECS is provisioning VMs. The ECI are provisioning containers. Right? Think of this way. And containerd, I'm not 100% sure. Containerd is basically the Docker's engine is called containerd. Serverless Kubernetes and the container service, those are all orchestration things. Orchestration means you get a lot of containers, or VMs, actually it doesn't matter, right? And then you need someone to actually orchestrate these, who talks to whom and how do they work with each other. That's that lab layer. And those are all things that we need to, if you use it, user needs to do these things. It's not a service that does this. User needs to, like Kubernetes, you have to say, I configure this pod, how many pods, pod can do what, and tons of parameters coming into that. And these are kind of the cloud native computing. So it's serverless is part of the cloud native computing. This is coming from, this is one of our slides for the CNCF things. Okay, so now I mentioned this a few times, function compute. So before that, any other questions? Just some warning. Now I'm going to get pretty technical, and eventually I'm going to see some code.
I have a question, but maybe it'll be answered in part. Generally, more often, at least for serverless, the key to security is some kind of least privilege kind of setup. I mean, well, is that the way you do it? Is that going to be, discussed in part 3, or
can you define what's least privilege mean?
Just basically, so that the function is very circumscribed where it can go, what it can do, what levels of access it has.
Oh, I see. Yeah, that definitely is one of the part, and you're going to see my demo.
Okay, great.
Yeah, it definitely has, and to at least to me that part is a little bit confusing because you need to set up a lot of permissions and roles and RAMs, all these things. That's to me is the most confusing part of the serverless because we still cannot get away with these. Serverless kind of can get, you don't have to maintain your resource, you don't have to maintain your scheduling, but permissions and the roles and the policies, you still cannot, because only you knows what you can do. Otherwise, we're just going to block you from doing anything. So that part, definitely we have that. And we have to do that. We're trying to simplify that, but so far it's, at least for some new users, it's still pretty confusing. In any case, any other questions? Okay, yes.
So according to your talk, you know that the serverless is pretty cool, but are there some data comparing the usage for container, VM, and the serverless?
Data, you mean like usage?
Yeah. Like I'm just I'm like what are the main customers and the suitable scenarios for using this serverless?
Sure. That's a good question. So IS is definitely still the big brother in the room. So as far as I know, AWS, Azure, everywhere, IS is still the biggest. But serverless is the newcomer. It's the represent the future. And serverless and the container are both new technologies. And as I mentioned before, it kind of depends on whether you have some system admin guy who like to configure your own thing, or you just wanna, let the cloud provider take responsibility of that. As far as I know, that's totally unofficial. Lambda has a pretty nice adaptation, and if you ever go to any of the serverless talks, there are tons of Lambda talks. And the thing is, it's the Lambda's client come to talk, not themselves. They don't even need to promote it. It's the client coming to say all kinds of different scenarios. There are plenty of, I call them Lambda shops or serverless shops. They don't own any VMs anymore. Their whole thing was built from Lambdas or functions. So it's definitely a change. There are, probably I will leave that for the end. There are definitely still adaptation barriers and the scenarios that doesn't apply. That's kind of a given because you give up the configuration flexibilities. So that definitely means you cannot cover all the scenarios. It's just something that can suit maybe a big chunk of the scenarios, but definitely not all. For the big ones, they still go to VMs and do their own thing. But anyway, we can. Yes.
Oh, so I was hoping that from context I would be able to figure out what serverless meant, and I'm still very confused. I understand the difference between a container and a VM. Serverless has to be running on.
So serverless is, again, as I said, it's a loaded word, buzzword. Nowadays, not everybody, but people use this word kind of just as a buzzword. So everybody has different. If you look up, I think everybody has a little bit different definitions of that. So let me give you my definition. My definition is serverless is a server that you don't have to deal with resources basically, or infrastructures. That's my definition. Container itself is a resource. If you get a container and then do something on it and start to load on your programs, to me it's not serverless.
So would software as a service be serverless?
No, maybe let me. Probably the best way to think of it is when you provision a VM, you're provisioning something that's going to be around a certain amount of time, right? And even a container, you're provisioning something, you personally are, instantiating something. Serverless is basically, you tell the system, I want to run a function. The function, then the system says, okay, for me to do that, I need the following compute, the following whatever. It provisions what it needs, runs it, and then tears it down into, as soon as it's done. It's completely ephemeral, and you personally have no say in what gets provisioned in order to execute that function. The system, the cloud, does it all on its own, and that's why it's called serverless, because you are not provisioning a server.
Okay, thank you.
There's like a 5-minute or 50-minute limit on Lambda, right? So is there the same kind of time?
We have that limit, yes. But that's not a core part of serverless. It's definitely implementation, and I give you a sneak peek. We probably will relax that, at least on Alibaba side.
So make it a serverless, like every time a new function is being run, there is some bootstrap
Code start.
The runtime is running. So how does it really compare against the container? There is a spin up of container runtime is already hot and running the code, but it doesn't make it serverless if he adds that additional overhead.
Sure. I think I can answer that after this, because that get a little bit more complicated. Any other questions? I get through this and I'll come back to these discussion. So at least everyone now know what is serverless. At least have some idea. So one thing is I want to make sure that serverless is not Lambda, it's not function. It's more than that. But that gentleman summarized definitely is true. If you look at, let me go back to this. All these things, they except the serverless Kubernetes and the ECI, everything else is like that. You don't need to deal with computer. No, not any resource you have, and more importantly, you have no say about what resources are going to be allocated to you. All these API gateway, log service. Log service, they will go, you just say, here's my data, record that. They say, okay, you're not going to say, I gotta run this on that container or on this thing. That's the issue. So it may not be a compute, but it has to be, you don't have to deal with any type of resources. That's the kind of my definition. So here's a little bit deep dive into function compute. Function compute, basically, we are fully managed. All these fast basically means it has to be fully managed. Means the code is running on the server side, on the cloud side, not on the client side, on the cloud provider side. And we decide where to run what. And it basically provides you the compute resource. This is really a compute serverless compute. So there's serverless storage, serverless log service, serverless, and this is a serverless compute service that allows you basically you run code, you submit your code, and then we find some resources to run your code. We will not tell you where we find it, but we will give back the result of what your code runs. So that's the basic idea. I don't know if I make it a little bit. So here's some, probably cannot see very clearly. That's the CNCF. Last time I checked, maybe they added something more. A few weeks ago I checked. That's their landscape. Anybody know Anybody know what is CNCF? CNCF is a new foundation that is cloud native foundation that is actually really the forefront to promote all the cloud native services, and it has basically pretty much all the big enterprise supports on that. It's kind of the most hot thing now. So that's their definition, and you can see Alibaba Cloud, because it starts with A, it always comes first. Because that's our logo, the Alibaba function compute. That claim we are number one, right? And then we have these are really some highlight of our service. That's actually kind of similar between AWS, GCP, Azure. They're pretty much similar. So it's one very important thing is it's event based. It's not. You can, of course, you can still do it in traditional way. Say, here's my cloud, here's my code. Please run it once, run it by like traditional invocation. But in a more idiomatic way, it should be more like data-driven, event-driven, right? You can monitor all these things on your table store, log store, all these things. I'm going to mention that. All these things, you can monitor them. We call it, in our term, we call it a trigger. In the AWS term, it's a bit different. We call it trigger. Trigger means something happens, it can trigger you. You are going to define your trigger means you define what exactly happens. For example, I will put an OSS example or the S3 example, right? You're going to say in this bucket, if there's a file name starts with extra slides happened, I'm going to do this. Right? That's the basic idea of that event driven. And if a queue, say like Twitter, right? There's a new thing Twitter tweets into their file host. They're going to get that out and do some process. That's the event driven. So that's very important. Developer friendly. That's our marketing guy says. I'm not 100% sure, but that means basically you have those language support. That's another thing for the pure fast or the function compute type of fast. You kind of confine with what the platform has. So currently we support Java, Python, Node.js, and PHP. And PHP is not there. So you can only write in those functions. If you write in, say, Go, if the platform doesn't have this support, you're out of luck. You definitely need monitoring and the logging, right? Otherwise, you don't know what you're doing. And fine-grained. That part is actually pretty new, pretty interesting because we are built to at granularity of 100 milliseconds. So if your program runs 500 milliseconds, that's all you get built, not even a second. So you can run millions of those small, tiny scripts, each run a few milliseconds, a few hundred milliseconds, and you get built upon that. Instead of, I think VM level is built on minutes or something. So that's something is pretty different from the traditional computing ways. Okay, I just made up this thing before the talk. I maybe missed something, but I saw AWS. I don't know if AWS. I think the reInvent, they will have this Lambda release history. We released preview in last year, 2017, April. I kind of look at their features and just whatever we have, we just put there. All the yellow ones are language support. So that, as I mentioned, if you don't support language, that's particular language that you cannot use. If you are, say, a Go expert, but we don't have Go language support, then you're out of luck. So that is pretty important. You can see that we have all the yellow ones are Python, Node.js, different versions, Java, and PHP. And then the green ones are those triggers. The triggers, I remember I mentioned, those are the connections between other sources, other cloud sources. For example, I mentioned there's API gateway, log service. API gateway is something you can say, if I call, API gateway gives you basically a URL, like HTTP URL. You invoke that URL will be designated to a function. So effectively, you get a backend for that URL. That's what API gateway is. And we have CDN support, RDS support. We recently added RDS support. That means, so if you have, I'm not 100% sure what specific database is that, but say your MySQL, right? MySQL, if you insert something, You can say, when I insert that, I call my function. Give it what is inserted, and then you can use it. So that's a very important trigger. We have 1, 2, 3. I cannot count. Maybe I missed something too. We have about 10 different triggers in the system. So you can work with so many different services. And then the light blue ones are the tools. We have CLI, we have some templates, we have fcdoc, which is a local anyway tools. And then we have the red ones. The red ones are the features that I highlighted, other than the basic features that you are able to submit some code and it runs. These are the features that I highlight. Those are kind of, especially the last few of them. These two are the unique ones. Nobody else has that. We have NAS support and custom domain support. They will be in my demo. Hopefully they all work, so you can see how awesome those features are. Those are the new features. And we're going to, we're constantly building new features.
Question?
Yes.
Could you elaborate on future language support?
If there are enough demand, we are. By the way, we are a very small team. We have about 20 developers. We are very customer focused, and if there are big demand, we're going to support them. It's just we're swamped. We have only that many resources, human resources. Any other questions? Okay, so here is a kind of high level illustrate how it works. Right? Probably I have already mentioned that a few times. Basically, you can see on the left side is this is a OSS logo, basically S3 logo. You have the blob stop, right? Something happens, you emit events into the function compute, and then that is the code. It's tiny, I know. It's but you just write some code. The thing is that code is, think of that in the traditional way. You have a main class, right? Normally, most language has a main. We defined a specific function interface for you. That this is basically your function's main. So again, I will show you the real concrete example. There will be code that actually run in the demo. But every different cloud provider and different language has a little different ways of defining entry points. So this is that thing is the entry point of, I think that's, I didn't even say maybe a Python code. So that's the entry point. You treat this as your main entry. Just if you write on your desktop something running on your locally, it's main thing. You just swap that in with this. What the parameters are all the events coming. So that's why it's event driven. The events coming. So the parameters, the input will be the events. The output, in general, every language and cloud provider is a little bit different, but in general, the input is always the event, and the HTTP, all these passes, queries, headers. What's out is the HTTP response. What you are putting in the header, what's the HTTP status code, what's in the body. That's the norm in a normal way. It's like that. So inside that function, you can call to again. In most common cases, those functions will not just be doing huge heavyweight, say, do some thermonuclear simulation something. It's not for those type of computing. It's more for those simple and lightweight calculations. Just say insert this into a database, something like that, or put that into a log, put that into a ETL, something like that. So normally it also works with another services. That's why it becomes a chain. So if you insert something or do something in the next service, you can also connect that to another function. So you become a chain processing mechanism. I've seen many talks by the functions customer. They're all doing this way. Okay. And yeah, here's a use case, right? So this is a more of a web page, because at least our customers, many of them use this way. So they call this, they put a HTTP front. They can use API gateway. API gateway, as I mentioned, is basically giving you a HTTP endpoint. Or we actually, I will show you the HTTP endpoint. We have a HTTP trigger that you don't have to use the API gateway. But in any case, the user, basically you can create a website and your customer can click this, which will result in some function compute get called. And that function can do, say you want to render a picture, right? If you call this, you want to render a picture. This function can render a picture, it can go to S3, can go to table store, or do some AI. I used to have last year we did some demo with the CNCF guys. They give you a picture, you send it back, call some AI services again, then send back to you, what do you think this thing is? Like this dog, it's a cat, thing like that. You do that, and coming back, and going back, as I say, it's a response, more like HTTP response going back. Then the front end user can see, oh, this picture, let's say this is a cat. So that's the very simple way of using this. You can go to marketplace. That's basically the very common use case of how you do the function compute. Any questions? You have a.
It seems like one of the directions that this is fated to go is standardization, where you don't care what the underlying operating system is, you don't know whose cloud you're in. How far are we down that path? Once I write these functions, can I run them anywhere, or?
You definitely can run in most of the cloud providers. Now here's the thing. It abstract away, as you said, the operating system, VM, the resources, but it didn't abstract away the interfaces and all these cloud providers services. So a typical use case is, as I mentioned, this. All of these, actually, you can see this. All of these are Alibaba Cloud services. If you want to move it to, say, GCP or Lambda, then you have to swap out every single component here. Your function probably doesn't change that much, but your interfaces all changed. So in some sense, it's not the interoperability of pure function as a service is not that good. It does allow you to don't worry about operating system and the resources.
But it's interesting because what you're basically saying is that serverless right now has greater vendor lock-in than say containers, which are theoretically,
less. Yeah, especially now Kubernetes basically runs everything. So
so basically, this use case is saying that for a general website, general web service, instead of having a centralized place where you define a bunch of endpoints, you basically decouple the whole web service into a bunch of, functions.
Yeah.
Functions correspond to one API.
Exactly. Or one URL, something like that.
Basically, there won't be a main function. The traditional main.
Yeah, there's no main function in your code. And the cool thing is there's no VM. See that? You don't need if you normally host a website, you normally need to get a VM, right? Host a website. There's no VM at all. I'll show you, actually in my demo, I'll show you. You will see a website, there's no VM behind that. If there's no click, nothing happens. There's no VM, it doesn't even exist. That come back to the code start program. So when you click that URL, then the function gets triggered. There's a code start cost there. And then some resources will be generated or provisioned by our service to serve your request, which will be in milliseconds time, hundreds of milliseconds time. Depends on, we have done a lot of optimizations, but there has to be a cost, because if you don't, the key thing is if you don't do anything, we are going to scale down your resources. If your website has no one visiting you, you're not paying a penny. Because otherwise, normally, if I have a website that nobody is really actually click, maybe 100 times a year, but I still have to buy a light sale, $5 a month or something. You put it there, just in case someone click you, you're served there. The file is there, your whole thing is there. You put a web server, PHP, whatever, Nginx, Tomcat, whatever web server there, and then just wait. It's wasted. For this one, if nobody click you, there's no resources provisioned. No network, no VM, no computer, nothing, no CPU.
So on the flip side, if your website's getting hit millions of times a minute, what's the cost going to be like compared to the traditional, VM-based service?
So, like most of the services, actually it's the same thing pretty much. I mean, going back to 10 years, 15 years ago, right? People say cloud is expensive because if I buy a machine on my premises, if you do the math, if you rent an EC2 for a year, it's way more expensive than you buy a machine. It's like 1,000 for a very crappy server. The EC2 will be cost effective if there's elasticity there. If there's no electricity there, normally the cloud is always more expensive. If you have electricity, then good. You get a VM. The thing is, for the VM case, the only difference between this and the VM case is VM is coming out in minutes. You don't expect to get a new VM within milliseconds. You provision a VM. Even last week, the best one, I was pretty impressed. It still takes a few minutes to get that. And if you have a website that you know that will hit well during, say, holiday season, you provision your VMs in around now, pretty much start and then release them in January. That will save you time. If you keep these, it will definitely be expensive. And the exactly same thing here. If you keep on hitting millions and millions of requests, and your basic our servers has to serve all these constantly, it'll be more expensive. But as I said, if there's a cycle, there's elasticity. The good thing is for this, if there's suddenly users start to hit millions, you don't need to do anything. If you have VMs now, you are frantically going to say, getting more VM, adding to that. All these operation guys are going to crazy. Here, you don't do anything. Nothing happens to you. From user point, a website going from, say you tweet something going viral and suddenly get hit. You don't need to do anything, other than maybe cost, say, need to increase. There's some limitations we need.
Right,
we need
but
to.
it's interesting. Earlier on, you were talking about you have some rudimentary DOS.
Mm-hmm.
This seems to be susceptible to, something called denial of wallet.
Yeah.
Right?
Yeah.
You just basically run up the poor bastard's costs.
Yeah. So there are two things. For this case, right, you have authentications. If you go through API gateway, that's actually a good example. API gateway itself has the DDoS mechanism with it. It's more expensive. I'm going to show you the one that would going without the API gateway. You actually don't have to pay that, but we give a very rudimentary service that, as you mentioned, there's security, there are certificate management, there are other things. But API gateway takes care of these, but you have to pay for something like that.
Question. So the concept here, it could be like CPU intensive or memory intensive. Since the developer lose control of the underneath resource, who will be responsible for optimizing the workloads?
So again, this is kind of narrow on what I know of all the current pure fast operators. We all have a choice for the user to say how many memories they use. And I think pretty much everyone, others, whether say it or not, it's the CPU allocation is proportional to the memory allocation of your function. So say your memory function, I think most of us now, then you actually get half CPUs. It's not that flexible. The reason is if you get to that, it becomes being stacked. Because you get two-dimensional optimization problem. Most providers allow you to do one dimension.
So does developer actually have an option to throttle?
Yeah, that's exactly why I say you may need to call us because there's a default throttling mechanism there. Throttling means you can only have that many concurrent requests coming in. That's a default. It's not very high. That's to save your wallet. So if you know something is happening, you need to call us, and we can up. We have a very high limit internally. There's pretty much no limit, but we set that limit for the user just in case they will not get this. We've had the cases that user overnight wake up and with $1 million yuan bill, and they're panicked, like say, oh, what's going on, things like that. So we put that thing so that they don't expect to have like a website. You don't expect to hit 1 million times. We set it low enough so that things will not get out of control. So
is it not throttling that is like on a request from one user, or you can put the throttling behavior across
It's your resource because we charge you. Okay, maybe I didn't mention it clearly. We charge you by the resources you use. That's the main charge. We also charge you by that's the same pricing model for across all the cloud providers. We charge you on the number of invocations and on the usage. Usage is the number of CPU, number of memories you use times the time. So that say you want to use a 3 GB, you want a 3 GB function, right? And if your function lasted for a minute, that's a 3 GB times 60 seconds units. We charge you this way. So so the throttling is based on your usage. We basically say you cannot use more than 100, so in AWS case 1,000 containers at the same time. It doesn't matter who calls you, but we protect you that you're not going to pay that much. That's how we do the throttling. Any other questions?
Do you deploy this function to certain locations like global or something?
Yeah, we basically, remember, I don't know if you see the first slides, we basically are all there. We have US, East, West. I show you this, I will show you in the demo.
But does it restrict itself to a region natively, or would it?
Your function can definitely call any part, but there's a latency. You cannot get, say your function is deployed in US West. And if you want to access some database in US East, your latency will be a lot longer than if it's in US West. So in most, I think, cloud provider, we recommend people to, for the performance reason, concentrate your services into the same region, but do a duplication, do a failover over the different regions for the security, for the durability reasons. I can get into this a bit more. Okay, so this is the common usage. And this is, so the previous one is more like a HTTP call, direct call, and the second one is more of event-driven. So those are all the logos. Those are all Alibaba Cloud services logos. So this is pretty much a really ecosystem play. It's a little bit difficult for the user to use, say, Alibaba's function compute with AWS API gateway. It normally doesn't work that way. And authentication will become a nightmare. How do you even know who to authenticate? But in any case, these are all the triggers. I call it triggers. We call it triggers, or we call in Azure they call it binding. In AWS they call it connectors. But they're more or less the same thing. You can register on your source side. OTS basically is DynamoDB, S3, CDN say this happens, triggers this events, which is corresponding to a function. And the function will get the events. Every event has some specific format. So you can pass that format and do your own thing. That's basically the idea. And I've seen a lot of, as I said, I call them Lambda shops. Basically, they just put a whole bunch of services behind Kinesis, S3, something, and SQS, and some events coming, do all the things and then put it into a database. That's the very common way of use function as a service fast. Like I said, you can put in the Indexify, you can put in ETL, all these things. Any questions? So these are the two main ways I observe that main ways customers use fast. Okay. Let's see. Okay, now here's the exciting part. We're going to do some live demo. Okay.
So what is the packaging and deployment model for these functions in the cloud?
So it's evolving, and so far the mainstream and still are basically you're uploading your code pieces. I'll show you in the live demo. You have a code, you upload your code, some fraction of your code, and that piece of code will be run. That's the main idea. Google is testing something. I think Azure also has something like that. Google is testing a bring your own image function compute. Basically means you're not providing your piece of code, you're providing your own container image. And they will deploy your image and do the thing for you. I'm on a beta test, actually alpha test. I haven't really actually tested, but so far the problem I think is the code start. You have a small function, we can easily load you up. If you have a container image that is big, then the load up cost delay will be a lot longer. I'm not sure how they solve that problem yet. It's still in alpha. But so far, most of the public ones, you just upload your code.
Well, that seems to run counter to the idea behind serverless, which is that you don't have to sort of predefine your environment.
Environment, I think you can. It doesn't see, still don't have a say of what containers, what resources. It's not container, you don't have container, you have image. So all you can say is, this is the image, this is the environment my function will run. But when, where, how is still up to the cloud provider. Right? It doesn't really, it's a little bit different from the Lambda model. As I said, don't think Lambda is the only way to do function compute or function as a service. But if your definition serverless is you don't have to deal with resources. And the resources are very important. The resources will be taken away if you don't use it without your consent. As long as you don't use it, they can be. It's basically it's in the it's in the cloud provider's hands. They can reduce the resource to zero.
So is what you're describing essentially not sort of a Lambda style approach, but more of a more ephemeral container approach?
The Google new ones, yeah, I think sounds like that. Yeah, but internally, the only difference is the Lambda. Lambda actually doesn't use Docker, so but it still is a type of container. Right? It's still a ephemeral container. Your container will be destroyed. It's just the container's image is not customized. Lambda has its own image. They just plug your code into that image. As I said, that's the entry point. You plug that into that entry point, and then run it. But that's basically the difference.
But from a security point of view, right, the Lambda model then puts the burden on, say, AWS, to make sure that the environment is locked down and everything. But in this case, I could theoretically put up an image that is not as locked down, right? So
again, we can get into that more.
We can talk about it offline.
Yeah, we can talk about that offline.
But is this case an Alibaba service, or are you talking about the Google?
The Google one. Actually, it's yeah. We can talk about it more offline. But in highlight, the security boundary is really onto the things between containers. It's not within the containers. Actually, within the container, you can do whatever you want. The key thing is you cannot do anything bad to other guys' container. If you want to do something bad to, say, actually a very good example is in the early days, even now I think the same. Many people just get EC2s and do what? Do spam emails. In Azure, I've seen that too. Is that a security thing or not? It's a little bit iffy, right? They kind of get your VMs like with proper legally and everything is fine, but their function or their program is running something a little bit iffy. That is, I'm not a security guy, I'm not going to get into that. But in our model, we don't really monitor what you do to yourself, basically. It's like you do something to others is strictly forbidden. If your image has anything that is bad, trying to do something, say, to other guys' container, that is definitely forbidden. It doesn't matter whether you bring your own image or we have our image. That security the boundary is clear. It's like that. That is what. But yes.
So that would mean that if you, presumably, if there's a piece of code that's being called constantly, then you'll just, have the same piece of code be loaded and it'll get called repeatedly. And then when it's not used, it'll go away and then rehydrated when you need it again. If that code were somehow self-modifying kind of thing, it would mean that when it's serially reused rapidly, one user could affect another user, but when it's reused gradually, they couldn't.
Exactly. Yeah.
And you consider that to be the coder's problem. That's not the platform's problem.
Actually, I'm going to give a demo exactly on that part, right? Because it's a good segue. So because your code is getting read every time your code is loaded up and get run, there are two different cases. One case is you already warmed up. You are using a previously allocated resources. In most cases, container or some container-like resource. Right? So this thing, because that thing was already there, your previous basically becomes stateful. Your previous invocation run will affect your next one, and then you, as I mentioned, you don't have control of when it will happen. So your code needs to handle this case that you are the first time you come up, you don't have any context, and you have no previous runs. Say some user needs to establish a connection pool, and you have to create that connection pool and only get the connections out of that. And if it's the first time, you don't have that one. And second time, you already have one, you need to reuse it. And that's the difference. And especially if you want to write something to the file to coordinate, that's not possible. Because you never know where your container is run. As I said, you don't have control of where it runs or when it runs. So if you want to write something down, next time it's gone. Next time you get called, you cannot say, this time I write one. If you want to keep a counter, you write one. Next time I called, it's still one, because somehow, for whatever reason, we used another container to run it. Even if the previous container is there, we never guarantee we'll reuse it. So those are the things that kind of like pitfalls that the coders, programmers need to be aware of. Yes. Any questions? Okay. So basically, the demos are going to kind of focus on, I don't know if, I probably don't remember, there are some features that I want to highlight. Those are some features that I think is useful and good to have. The time trigger is basically a cron job. You basically put a cron tab. I don't know if you have Linux or other cron jobs, you can say, run this thing with the expression, say, run it on certain time of the day, certain days, certain seconds, and then your function will be run. That's actually a very common and popular pattern across the cloud providers. So everybody has different name: time trigger, timer trigger, cloud watch trigger, something like that. Second one is HTTP trigger. That's the one that I mentioned a few times. That's the one that you get around the API gateway. You don't have to go through API gateway to call your function directly without API, without a SDK. It just looks like a HTTP endpoint. We make this specifically for our users, because they complain that, why should I pay API gateway once and then pay you twice? So we say, okay, if you don't mind your security, some DOS or something, you can call this directly. And in the later time, if they need it, they can switch back to API gateway because it's the same UI. And third one is the NAS support. That's the one that I was going to really solve the problem of previous one. Previous one is you want to find a counter, but you cannot, because your containers may go away, may come back. We have a NAS. NAS is a network attached storage. Basically, it's like a GFS, whatever. It's a remote distributed file system that you can mount onto your drive. You don't have to do any mount. We will do the mount. You only have to provide us the configurations. Then we will do the mount, and then you will be happy that every time your function comes up, you are sure that whatever other function has wrote is accessible to you, so that you can coordinate. Fourth one is also these two are our unique features. You cannot find it anywhere in the other cloud providers.
So the storage, is this temporary storage, or whatever you write kind of stays the next?
Yeah, it's a permanent storage. That's why you can always use it. You know that it's a lot easier. Otherwise, the programmers may have this jitter of whether it's there. It's always there, and you access it just like a file. There's no difference. It's pretty much invisible to the user. Just magically, there's a file happen. There's a volume appeared that can be used by your function.
So this is more than just distinction between stateful and stateless storage.
This, yeah, sort of. Yeah, you can persist your state to that volume, and it will persist across runs.
So you can also load code from there.
Load.
So you can also load code from the storage.
Yeah, if you want, yes, you can. Yeah, people do that. So that's another big use case is this for AI, right? So machine learning, many of our customers does this way. because the training part is heavyweight. So they will use whatever. Some people also try to use TensorFlow things on that, but they're still working on that. But as long as you have the model, the infer part is relatively fast. You have the model, some user comes in, all you need to do is that's event-driven, perfect event-driven. User comes in, driven that event, you match it, run this infer on that model, say, oh, this guy likes, like in Alibaba case, likes shoes, right? Or this guy likes clothes, whatever. You do that very fast, you get that, and then serve something. So that's a perfect case. The problem is the models normally are very big. So if you wanna several GB of as5, I'm not an AI guy, but as far I know, many of the models are really big. So if you wanna start up your function and then go somewhere and grab that model, it's pretty time consuming. So they found out they can use, and that's one of the reasons we introduce this feature is so they can save their models on that file. And when their function comes up, it's already there. They don't have to do a full load. They can do a partial load and then run their inference. So it gets much faster.
But the load should happen to the network, right?
Load through network, yes. Yes.
And the cost of this is basically based on the amount of data or number of times I access this?
It just well, so every cloud. I'm trying to be not just promoting function computer. It's more like serverless. Every cloud provider is different. Some cloud providers, for example, S3. S3 is something you have to every usage is charged. This is not S3. This S3 is an object model. This is a file model. Our file model actually does not charge you the request. It only charges you the capacity. Some, I think Azure's model charge your request. So every provider is not 100% same. But you can fully take advantage of this one and not charge you the request time. Any questions? Oh, I didn't mention, I think I didn't mention the custom domain. So many users, remember, many of our customers use this HTTP mode. Then I'll show you later on. Our HTTP end code is you cannot define your HTTP. You cannot use your own domain to call your HTTP endpoint. Our HTTP endpoint has a specific format. The reason is otherwise we will not be able to serve you. You have to somehow hit our server, right? Then we can serve you. If you just hit whatever Amazon.com, there's no way it will not come to our server. So there's a specific URL that we registered and will hit us. But then user is like, if they want to move their existing website to us, then that won't work. Or they have to basically go there and switch every one of their links into our format. So we introduced this support. So user can basically have an interaction. User can say, if I hit, this is my domain. If I hit this domain, it will go to our endpoint, and we know what endpoint it is hitting. And then they basically can seamlessly move their website to, instead of using a VM back, it becomes a function compute backend. So that's something really, really useful. Anyway, I'll show you the demo. I think that will like really solve a lot of problems, a lot of questions. And how much time do we have?
20 minutes.
20 minutes? Okay. Okay. Okay.
Is that enough time?
I can do this demo. This demo, it's really a hands-on workshop. I used to do it like for 3 hours workshop. It's basically you write your first line of code to all the way to get this. But this, I'm just going to do a demo. The thing is, I cannot. Oh, I can see this guy. It's a bit hard for me to do the demo facing this way. Let me see. Oh, there's some delay here. Oh, it's actually still not easy. Okay, so this is our console. I haven't logged in for a while, so I will be logged out. This is it will prompt me to log in again. So okay.
Can you use the form?
Sure. But before that, let me describe you what I'm trying to demonstrate. What I'm trying to demo is I will write a function. So in this demo, hopefully I can finish all these demos. I used Java, Node, and Node.js and Python. I have 3 functions. One is Java, one is Node.js, one is PHP. The Java one is crawler. Basically, you give it a website, and it will basically go around and crawling the whole website using all the links. So it's a depth-first search. Basically, it does the depth-first search. The reason it can work is we use the NAS, use the persistence network, so that every run, it will put all these images into a certain place on that volume. Without this, if you just put it on your own local device system, it will disappear, and nobody can use it again. So we can put it there, and we also use that. This is difficult. Yeah, so for demo, I'm most likely will basically looking back. Meantime, let me show you the code. Okay, so here's the code. Here's the. So I promise you have code. So let's see. Let me try to see if you can. I'll increase the. I'm trying to increase the font. Is there a way to? Yeah, that's what I'm trying to do. I don't know how to increase the font here. Yeah, I don't. It doesn't work. Normally, the command plus works in browsers. This one. Is there any way you can see it, or is it really too small?
Copy to text editor.
Copy to a text editor. But that's difficult. I'm going to show you many different things. Anybody knows how to?
Presentation.
Where's the presentation?
What is full screen?
I think you go to
How to
edit, yeah,
preferences?
edit.
You know this.
We'll go back to view. And enter full screen.
Where is it? Oh, here. Maybe a little bit bigger. Let's see.
Then can you go in up in the 3 dots in the right corner?
Yeah, this one. Which one? This one? This one?
No, I think it goes to the right. Right there.
This one?
Yeah.
It will just disappear. Huh. Anybody knows?
There you go.
There you go.
Oh, I did this. Oh,
Okay.
just it's like this. Zoom. Okay. Okay. Let's show some. Where is the code entrance? Here. Here's the code entrance. So this is the entrance of this function, Java function. It's called. It has to be handled. This again is a little bit different every cloud providers. We define it like this. We have. Where's my class? Where's my class? Okay. Yeah, this is the handler. So in Java, just this is really like the deep down driving, the demo is we have this proto handler is our definition of the interface for Java. If you want to use function compute in Java, one of the handler has to implement. The handler has to implement one of the interface. This is one of the interfaces. It's called proto, and you have this is your interface. your class has to define your input type, output type, and the context. Context has different things that in it to help you. For example, it actually has the keys, secret keys, and it has your logs. Here we define something. Next UI is fine. Don't get into details, but here's the hand request. What it does is in the beginning, so this is the event. This is the event. So I remember I mentioned a lot of times event. This is the event. And each event, this time it's called timed crawl config. The reason is it's a time trigger based event. So it has, you can see that. What it have is it always has a trigger time. It has a payload, actually has a trigger name, trigger time, trigger name, and a payload. Payload is what you defined in your, you will see that with the payload. In a trigger, when you define a time trigger, you will say, this is my payload, and it has to be a JSON format. And we are going to insert the trigger time and trigger name into your payload, into your events. So this is the events you're going to see. Okay, so this is the events you see. Oh, by the way, what it has, the payload has this. This is the payload. So we're going to marshal and unmarshal it from JSON. The payload has the URL you want to run. This is the root dir you are going to put your files into, and then other configurations. Right? So this guy is going to get the configuration, do a bunch of things. It will have image crawler that basically just call that web page. This is per web page you create a crawler, and then you basically just call once and grab all the. Here's the new pages, right? So every crawler will say, I call this one, I dump a bunch of new things into it. And the cool part is because we are using NAS, we can do save history. Right? Because when you call the website, they're going to have the same URLs we'll get. It's a graph, right? You're going to hit the same URL many times. So we can save the history. And on startups, we can read the history. Somewhere there's a read history somewhere. Save initialize pages. We read the root directory, read the history, and then voila, we can run multiple times. I put a time trigger on it. Every 5 minutes, you wake up, read the history, say, oh, these are the URLs I still need to crawl. I crawl something, get some pictures, pretty pictures, and then dump it somewhere in the NAS file system. Okay, so this is what this thing do. Okay, so this is what the first function do. Where's my? Okay, so I pre-built. Oh, okay. Going back to this, build, right? At the end, what you do is this. This is a Maven. I don't know if any of you are familiar with Maven or something. It's basically a packaging. So that way we're going to package all the Java things into a Java. The Maven thing can do that. Put all the dependencies. The key thing is that in Java you need to, just in any language, you need to bring all the dependencies. Bring all these, compiled and finished, and then you're going to see in this case you're going to see something like this. You're going to have a jar, and then you upload this whole jar to the cloud. Okay, I already did that. So I have function compute here. I go to, so these are someone asked what are the regions we have. These are the regions we have. I think we have a few Chinese sites, Singapore, Australia, US West, and Japan, Germany, India. Yeah, we have all these. The thing I created was in Hong Kong, I think. Okay. And this is the services I pre-created. Image convert, image call. So this is a Java one. The Java one, it doesn't. Oh, one thing is important here. Let's see. Yeah, like this. Yeah, again, tiny. Let me. I think I can. Yeah. Here is the NAS mount point. In most of the EFS NAS thing, there's a mount point. You mount this to, this is the point you can mount it to your local file. So if you run some command, and then, I don't know if any of you are familiar with NFS, you can run a mount command, and then that NFS volume will be mounted onto your file system. So this is where we mount it. This is the mount point. So for all the functions, this is the place you can access your file. And it looks just like the local file system. There's no difference. Yeah, just to show you that, see this, what we used in Java code, we just say file reader. To read the history, we use file reader. When in the save history, we say file writer. There's no difference. Your code would run just as well on your local if you have a local function. You can run it locally. We actually have a local tool for you. You can run it locally. It works exactly the same as in the cloud because it's a file. Okay. So this is file, and we need to define what's the user ID and the group ID. Okay. So here's the trigger. Let me turn it on. This is the time trigger. The time trigger I said 5 minutes. Maybe 5 minutes too much. Put 3 minutes. Okay. And it will basically fire every 3 minutes. And this is the payload. I don't know if you remember that. Previously I showed that there's a payload part in the Java side. This guy. And this is the payload part. What it has the URL, root, memory pages, these things. And this is the event payload. So you put in this, basically we are going to crawl the always interesting TMZ website. We'll see what we get. Number of pages, every time you page 30 times, and cutoff site. Okay, so we have this. So this guy is going to run in the back end. In the meantime, so this guy is going to dump all the files to that directory that I just showed you. In the meantime, let's take a look at this. Okay. So this is another interesting thing. This is a static web page. Use a little bit tricky. I can show you the code. So I'm not a Node.js expert, but this thing is pretty neat. So this is a static website. You see that there's no nothing running behind it. Well, it is actually hosted here. So just like S3, I don't know if you're aware of that. You can, if you have a static index HTML, you can upload it at S3 and say this is my website. It becomes basically a hosted website. You don't even need to. You have an EC2. And it's super cheap because all you pay is just a few KB, MB storage. And if it doesn't hit well, it's pretty much practically free. And we have the similar thing here. Let me see. So I host it here, this bucket. So this bucket. So same thing, I host it, I put on this index file there, host it using this URL, and voila, we have a URL. And what does this do? This is an interesting thing. Let me see if I see it. Anyway, so this is hitting every command is actually hitting, as I mentioned, it was using front end like this, and then we have the back end as a function compute. So notice it's called index.js. Why? This is where your function code is running. So what this thing actually does is, invoking this guy. Sure. So this is written in Node.js. And what this thing does is, notice that this is Node.js function entry points format. Looks like that. In any case, this is what I call an HTTP trigger. What does it mean is, this guy has an HTTP interface. Okay. Again, I don't know if you can see it, but it looks ugly. As I mentioned, it looks ugly. It's a user ID with a region name, FC command, blah 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 blah. The function name, your API format. It's a very ugly URL, but it's a working URL. So this is the URL you can hit, and you can get things back. For example, we can just do this. You can see this. What it does is it query the CMD. Right? This is the query parameter. In the query parameter, if you have a CMD, it will basically execute that CMD for you on the cloud, on that function. So you can say CMD. Let's see, LS. Body. So this is a very tiny piece of code that, because we have the HTTP trigger, just this is all it has. What 30 lines of code. All it has. You can use HTTP to query this guy, and it will run this command on a local container and return the results. In this case, is command index, right? And here we can do something a little bit more. Let's just do this. Oops. Copy paste is not. This is not a fully developed. Okay. Oops. Too many. See how many? Okay. Remember, now I have a lot more than the previous ones. But I started that one. Now we have more, 477. Those are all the images. The Java one just crawled. They crawled image, download it, computed the MD5 to dedupe it, and put it there. And now we have another function runs. Remember, it can run anywhere. You don't know where it runs, but the NAS file system is the same. They share the same file system. So it can run anywhere, but if you do this, it will always go to that NAS same file system. It will get the results back.
I'm curious.
Yeah.
The two features that you were saying were relatively unique to NAS and the custom domain.
It is unique, not relatively.
Custom designed for an industry of website scraping.
Oh no!
I'm just kind of curious whether or not that was the genesis of those features.
No. This is just I come up with this idea that can kind of use all these features together. This is a demo. It's not a common use case of our customers.
Okay, I was just kind of.
They don't do web crawling. Yeah, that's not really for people to do web crawling. This is just an example. Let me see if they have more now. If not, it's okay. Oh, we have more now. Okay. So now the last one. So we have another one. Image convert. We have another one, image convert. So this one is written in Python. What it does is, again, NAS, right? It's used the same thing, see the NAS root. So because it has NAS, it knows where the files are. And it also, again, this is using a HTTP trigger, means it has a HTTP at the end. It has a HTTP endpoint naturally coming with it. You don't have to do anything. You don't have to do API gateway. You don't have to do anything. Coming with it. What it does is it looks at the query parameters. Look at query parameters, the action. Right? And the action is, if it show, it basically shows the picture. The file name is using the path. So you put the path with the path. Where is the path? Yeah, here. So you get the path. Basically, you use this thing as, because the file is already in a NAS, you put this URL with the file path in it, and then it will grab this picture and do what you want it to do. And the neat thing is, I put it at the end, you can see this. At the end, it will say, templates. Where's the templates? Anyway, we have where's the template? We have here. Yeah. We already embedded another index.html. It's a web page. It's a static web page. This function will grab this web page, replace the image like entry point with the new image, processed image, and then serve it. So it effectively becomes a web service. Let me show you this. first thing, let's grab a file. Right? Let's try this guy. The thing is, the interesting part of this demo is nobody knows what's in the file until you see it. So I don't even know. Let's try to grab something a little earlier. It has to give me this. I don't want this. Anyway, I forget. I gave up. So let's see. Let's see if I can get something. Or I can just copy from this. Sometimes it's easier to copy this. Oh, okay. That's a new image. That's a new image. And if you look at the code says, if action is rotate, let me do something interesting. If action is face detect, it will do some face detection because it's loaded with some rudimentary image processing Python tools, CB2, WAN, something like that. Okay. Remember, we haven't used any VMs. None of them has anything. There's no VM ever. You didn't touch any VM. Let's see if the face detection works. This picture is a little bit small. I don't know if it works. It actually worked. See? You can see a small face detection there. Okay, so now you basically have a website that user can hit, and it will come back with some image and image processing, and you can do more. Like this is basically your playground. Inside that, you can add different actions. Let me see. You can add more and more these things. Script, just like that. We'll do the action, we'll do something, process that image, send it back. You now have some kind of toy to play with. It's kind of fun. One last thing. Look at this URL. I don't know about you. It looks ugly to me. Right? It's just blah 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 things. So users say, if I have they have a customized domain and the website. They want to serve this thing. They don't want to use this. So in the there's a feature called CNAME domain. So if you have any of your domains, you can register it. So basically, your domain, I borrowed it from my friends. If this is your domain, you can say anything. It's a pattern matching. Anything start with TMZ is calling this service my function. So we are going to redirect you if you have this type of queries. And let me show you how this works. Yeah. Let's just have some fun. Let's try another. Try another. Okay, we have a lot more now. I cannot find anything. Okay. Go back. I'll type. What did it say? It should be okay. unable to open that image. Okay. That image is. Okay, let's see. Okay, we get a new picture. That's the newly crawled picture. You see the URL is much better now. URL is much better now. The path's still ugly, but that's definitely just for this application. The URL is much better. So you basically can create your own website without using any VMs. And the good part is the VMs, we're going to manage all the VMs resources for you and auto scale it. If you use VMs to be backend, you either waste your money or when the load really comes, you are going to frantically trying to add more resources. Okay, I guess that's pretty much my demo. Then that's last page. Yeah, that's pretty much my. Yeah, that's my presentation.
Right.
Thank you very much. Any questions? We can sync offline. There are a lot of things I can tell you. And at the end we have raffles. We have this random idea number already, right?
Well, there's 1 through 15.
Okay. So some T-shirts. That's the Double 11 festival. 200 now. 20 billion. Yeah, 20 billion GMV. Just remember that number. One day, 20 billion GMV.
Okay, 1 through 15. Hit the generate.
Yeah.
13. So go down to 13. What is it?
Amit.
Hey, Amit.
You can pick. One is bigger than another one, I think.
You won last time.
Really?
No,
you can pick. You can just. They're pretty much the same. And,
one more. 4.
John.
Hey, John.
They're not. They're deceivingly large. It says large, but it's not really large. It's the Asian style large. So.
I'll give it to my wife.
There you go. Well, thank you all for coming. If you're interested in sponsoring or speaking coming up in January, February, or March, please let us know. Ryan, thank you again. And do you want to just mention if somebody wants to get a trial?
Oh, yeah. So that's the whole thing. Another best part of that, all my demos is free because we have a very high free tier. It's like 1 million requests per month is free. So I'm pretty sure you do play with yourself, like playing your some toy programs will never hit that 1 million thing. So it's practically free. You can sign up on alibabacloud.com and play with it. If anybody interested, I have the demo code. They're all in GitHub. I have demo code. I have a demo tutorial page website, and you can follow it one by one and use the code. You will be able to build the same thing, just exactly like that. What's the best way to send it out to the group?
You can just post it on the site too.
Oh yeah, I'll post it there. Yeah.